Okay, here's the deal. I think we're all getting a little carried away and treating AI like it's pure magic. While these technologies that we have are very impressive, knowing what they are and generally how they work can actually go a long way. So in this video, I'm going to show you exactly that. We're going to talk about AI, specifically LLMs, and how they work. By the end of this video, you'll have a high-level understanding of what's actually happening under the hood when you type in a prompt. We're also going to talk about some key differences between some of the major models out there, specifically Claude and GPT. Once you kind of have a sense of how AI works in your head, it stops being a mystery. You'll actually be able to write better prompts, understand what's actually happening under the hood. You'll also be able to have a general sense of which tool you want to use for the job. And most importantly, you'll be able to build better products in the process. Let's get into it. All right, so here is what we're going to be covering today. So first, we'll break down what an LLM actually is. And spoiler, it's not magic. It's literally just autocomplete on steroids. Second, I'm going to show you a visual that I think could go a long way for you in having a deeper understanding of AI models. Third, we're going to talk about how these models actually were trained and why GPT and Claude could feel somewhat different even though they were trained technically on the same internet. And finally, we'll connect it all so you understand what's really happening when you type a prompt and why models sometimes hallucinate. Let's get into it. Now, if you don't know me, I'm Sunny. I'm a serial founder now on my fourth startup. I'm a former senior engineer at Bloomberg and Shopify, and currently an adjunct professor at Columbia Business School, where I teach tech. Listen, I've been building software for over 15 years, well before AI, and I've made all the mistakes so you don't have to. And I'm here to help you actually understand this stuff and potentially get some products out there into the world. Let's get started. But first, here's the deal. AI is moving at a dizzying pace right now. Every week, it seems like there's a new tool, a new model, or startup claiming that it's going to change everything. And I get it. It can feel completely overwhelming. But here's the best way to approach all this change. Learn the foundations once and use this as your mental model for everything new that comes out. Because under the hood, all these models essentially work the same way. They're nothing more than just statistical models. The core idea isn't changing as drastically as many would like you to believe. So the next time something new comes out, you don't need to start from scratch. Just ask, okay, what's actually new here? And then try to contextualize it into your own existing mental model. That's how you stay current without losing your mind. Foundations first. Everything else is just flavor. Okay, so we're actually just going to start with the very basics. I'll start with this. When people refer to AI like Claude or ChatGPT in particular, they're really referring to large language models, LLMs for short. AI really is a broad umbrella term that captures a lot of different technologies, but we are going to focus on LLMs today. And an LLM is nothing more than a statistical model. That's it. Think of it like autocomplete on steroids. Its entire job is to predict the next word in a sequence based on all the words that came before it. There's no secret sauce, no hidden consciousness, no sentient being here. It's just probabilities. But here's the question. How does an LLM actually work though? Like, how do the predictions come through? Well, the best way to understand it is to visualize it with a graph. I'll show you what I mean. All right, so let's play a game. Imagine a very simple world that only had 3 words in it: dog, car, and cat. Now imagine we plotted those words on a graph that essentially represented meaning. Here's what that graph would look like. Dog and cat would live somewhere near each other because they share meaning. Both animals, both living things, both pets. Car, on the other hand, is way over here. Mechanical, living, just an entirely different category. And this distance, this geometry, is the core of how language models think. Words that mean similar things will cluster together, and the opposite, of course, is true. Words that are in entirely different categories will be further apart. And this is the part that many people get wrong. These models, they don't understand language the way that we do. They're not actually thinking. They're literally just doing math. every word or phrase gets turned into a vector, which is nothing more than a fancy word for the address of where that word or phrase lives on this graph. And the model is just moving around that space, trying to land on the next likely point. It's not consciousness, it's just math. That just happens to feel like thought. So I want to add a little bit more to our original visual. As you can see here, I have labeled my y-axis and my x-axis. So on the y-axis, we are basically putting down a scale of things that are more animal-like versus more object-like. And on the x-axis, our scale is going from more living to more mechanical. And because we've structured our very simple world in this way, it allows a very simple model to cluster together the words dog and cat together on this upper right-hand quadrant, and car to be all the way down here on this lower left quadrant. Now, this is essentially how large language models work, obviously amplified to a very high degree, because imagine if instead of just two axes, we actually had thousands of different axes. And that's essentially what large language models are dealing with. They're dealing with thousands of axes, each dimension capturing something subtle: tone, time period, formality, even emotion. You can't visualize it, but the math works the same way. And once the model knows where every word or phrase lives in this massive meaning space, it can use that, and it can actually calculate the space between different words and phrases to predict what comes next. And that essentially is nothing more than autocomplete on steroids. Now, one might ask, how do these models figure out where these words or phrases should live? Well, it comes down to training. Now, what exactly is training? I'll start with a very simple version. Models start with actually random positions for every word or phrase. It's complete chaos. But then these models read billions of sentences, books, articles, web pages, and start adjusting those positions. Words that appear more often together will move closer. Words that never really co-occur will drift apart. See, the word dog will likely to have appeared next to words like walked, barked, pet numerous times. So naturally, those words would cluster together. For the word car, they will have likely appeared next to words like drive, engine, and garage. So that's a separate neighborhood. Those words will be clustering together, but likely further away from the dog words. Now, that's how the model learns meaning, not by understanding, but by noticing patterns in how words and phrases are actually used. Now, here's where it gets interesting. Every LLM trains on roughly the same corpus of information, which is pretty much anything and everything it can get its hands on the entire internet. But when thinking about what makes these models different, it's less about what they've been trained on and more about the methodology and how they are trained. Pretty much all models use something called RLHF, which stands for reinforcement from human feedback. It learns what human beings, prefer. But Claude builds on top of that, uses something called constitutional AI, which is really just alignment through basic principles. Now, if you don't know what those mean, no worries, we're going to go over it in a moment, but I do want to make this one point. So when someone says that one model feels safer or another model feels more creative, it's not that one model is literally smarter than the other. They both learned the same way. The difference, though, is what guardrails they were given afterwards. Training data isn't the moat anymore. It's the finishing touches. So I want to go a little deeper. Again, RLHF stands for reinforcement learning from human feedback. And here's a super simple metaphor for it. Think of it like training a dog. You give the model several possible responses to the same prompt. Then humans, actual human beings, rate them. This one's great. This one's okay. This one's bad. This is the type of responses that humans will give. The model then uses those ratings to train a reward model. Basically, it learns what kinds of answers actual humans, prefer. Then Through reinforcement learning, it adjusts its behavior to maximize that reward. Over time, it gets better at anticipating what people want, being helpful, polite, concise, or creative, depending on what's been rewarded. GPT models use this approach heavily. That's part of why it often feels very eager to please, because it's literally been trained and optimized for human approval. Now, Claude, on the other hand, adds an extra layer called constitutional AI, and this changes how it learns. Claude is grounded in a written set of principles, its constitution. Think of it like raising a kid with a rule book with the following rules. Be helpful, but don't do harmful things. Be honest, even when it's inconvenient. Respect privacy. So during training, the model uses all of these principles and others to critique and refine its own responses, effectively learning from its own feedback, not just from human raters. And that's exactly why Claude sometimes feels more cautious or reflective. It's not just trying to please you, it's actually just trying to also follow rules about what's right. Now, to sum up, here is the key distinction. RLHF asks, what do humans like? Whereas constitutional AI asks, what should we do? RLHF optimizes for human preference. Constitutional AI optimizes for ethical consistency. Now, neither is perfect. Pure RLHF models can make models almost too agreeable, eager to help even when they shouldn't. Models with constitutional AI layered in can make models too careful, refusing to do things because maybe a principle got triggered. Now, here's what people don't realize. When you're using Claude or ChatGPT, you're not just talking to AI, you're talking to a specific philosophy about how AI should behave. GPT says the customer is always right. Claude says, here's what we think is right based on a predefined set of principles. That's not about which model is better. It's about knowing which trade-offs there are and which trade-offs you're willing to make. Flexibility versus caution, helpfulness versus responsibility. And understanding that trade-off is very important in knowing which tool you want to pick for the job. So let's connect all of these concepts together and talk about what happens under the hood every time that you prompt an AI tool. So as soon as you hit enter, the model will convert your words into coordinates in this meaning space. Then it predicts the next word, the one that fits best mathematically, and repeats that process over and over until it's done. It's like an endless game of autocomplete, except the model is playing across thousands of dimensions that you cannot see. So when a model hallucinates, they're not actually lying. They're just picking the next nearest word in space, even when that word is factually wrong. The geometry says it fits, so the model doesn't know any better. All right, that's a wrap. Here's what I want you to take away from this video. Firstly, LLMs are nothing more than statistical models that predict the next word based on math. Number two, training these models is pretty much just pattern recognition at scale. But the biggest takeaway here is this: AI is not magic. It does not possess consciousness the way that humans do. It's just math, statistics, and pattern matching. And once you stop treating it like a mystery and start treating it like a system, everything changes. You write better prompts because you understand what the model is actually doing. You build better products because you know where the limits are. And you stop being impressed by hype and start evaluating tools based on how they are built. Here's what I want you to do the next time you use ChatGPT or Claude. Think about what's happening under the hood. It's plotting your words in space, predicting the next most likely point, and repeating the process. That's it. That is the whole trick. And here's the bigger lesson. The best builders aren't the ones who think AI is magic. They're the ones who understand the system and design around it. If you stuck around till the end, I really appreciate you. I will see you at the next video.